How do I test my array algorithm? How do I debug an array program? What are the most common array errors? This is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 48th and final video in the Introductory Programming in Java full course. It is the 9th video of the final lesson, Lesson 7, Arrays and ArrayLists in Java. In this video, we're going to look at some common array and ArrayList errors and testing and debugging strategies for arrays and ArrayLists. It's a lot of material, so let's get right into it. This program is called ArrayBugs.java. I'm going to demonstrate the bugs using an array, but you can make these same errors with an ArrayList as well. Most of the code is commented. We'll take these one at a time. At the top, I've defined an array called numbers, which contains the digits from 0 to 9 in order. And my first block of code finds the largest value in the array. I first set largest to number sub 0, and then I have a loop which compares the second through last elements of the array to largest and replaces largest if it finds a larger element. That code reads, for int I equals 2, I less than numbers.length, I++, if numbers sub I greater than largest equals numbers sub I. So for all of these bugs, I'm going to suggest you pause the video and look at the code carefully to see if you can spot the bug before I tell you what it is. So pause the video and find the bug. Did you find it? Let me run the program. It says the largest value is 9. Well, that's correct, right? Nothing wrong with this? But let me throw a 10 into this array, right after the 0. That's the largest value in the array now, right? I'll run the program again. And it still tells me the largest value is 9. This is possibly the most common array error. It's also possibly the most common loop error, and surprise, it's an error in a loop that's looping over an array. It's an off by 1 error. I've written it in a slightly sneaky way. I want to iterate from the second element in the array through the last. I put the element at index 0 in largest, so I want to start comparing at element 1, not element 2. But I started at element 2, so this loop never considers the element at index 1. It's only going to be wrong when the element at index 1 is the largest element in the array. But it's wrong, so we fix that by beginning the iteration at element 1. Not 2. Okay, let's comment that and uncomment the next code example. In this example, I'm going to total values in the array. So I've set a variable total to 0 before a loop, and then I'm looping over the elements with for int I equals 0, I less than or equal to numbers.length, I++. And then inside the loop, I have total plus equals numbers sub I. Pause and find the bug. Did you find it? I'll bet you did. Let's run this. Ooh, and we get an array index out of bounds exception. This is an off by 1 error on the other end of the array. We're trying to index into the element at length because we've used less than or equal to numbers.length as our entry condition. But the index of the last element is at numbers.length minus 1. So we fix that by writing less than, not less than or equal to. I'm going to uncomment example 3 now. In example 3, I'm filling an array called values from a file. I send it to a fillArray method. I then loop over the array, totaling the values, and then I average the values by dividing by the length of the array. My loop is for int I equals 0, I less than values.length, I++, and then value total, which is initialized to 0 before the loop, plus equals value sub I. Pause the video and figure out what's wrong here. I'm going to run this program, and it tells me the average of the values in the array is 61.74. Is that right? Well, no. I averaged the values in a spreadsheet and I got 88.2. So what went wrong? In this case, I filled the array from a file, but the file contains only 70 values, and my array has a length of 100. Recall that all of those unfilled locations in the array will have been initialized with zeros. So I'm adding in 30 zeros and then dividing by 100 rather than 70. Before we look at more bugs, let's talk about how to write code that will not have an off-by error, how to debug it, and how to test it. First, if you're going to iterate over all elements in an array, you should either use the pattern for int I equals 0, I less than array.length, I++, or you can use a structure called the enhanced for loop. I have an example here. The syntax is the keyword for, and then in parentheses, you are going to declare a loop control variable, which is the data type of your array elements. As we're looping over our numbers array, that is int. So int element. This is not going to be an index into the array. This variable is going to take on each element in the array one at a time, once for each iteration of the loop. Then colon, and the name of the array, so numbers. Inside the loop, I'm adding element to my variable new total. You can't have an off-by-1 error if you use the enhanced for loop, so it's a great choice if you're only accessing the values of array and not the locations. In other words, if I don't need to change the value in the array, or if I'm not trying to iterate through parallel arrays, the variable element is going to be a copy of each element in the array. If you're not iterating over every element in the array, then you need to remember that array indices begin at 0 and end at length -1, and I recommend drawing a picture and stepping through your algorithm by hand with some sample data. These loops are quite simple, but an algorithm such as a selection sort is a more complicated example in which you could easily write an off-by-1 error. What about the case of the partially filled array? One strategy is to use an array list rather than an array. That way, the size will be correct and there won't be any non-data elements in the array. Another option is to put a sentinel value at the end of the data and make sure you're totaling to the sentinel value and no further and dividing by the number of valid elements. Once you've written an array processing algorithm, you'll want to test it thoroughly. Choose test data that will test ordinary cases and edge cases. Edge cases might include a very small or large array, for example, an array of one element, or partially filled arrays. Put elements of interest in different places in the array, especially at the beginning and end, and do that for arrays of different sizes. What an element of interest is depends on your algorithm. In our algorithm, looking for the largest element, the element of interest is the largest element in the array. Does the algorithm work if it's at the start of the array and at the end of the array? This one did. Try the second element and second to last element, and several locations in the middle. Let's move on to our next category of errors. Now, as I uncomment example 4, you can see Eclipse is giving me a syntax error, but I'm not going to mouse over it yet. This is just 2 lines of code, int open close square bracket more numbers, and then more numbers sub 0 equals 5. Pause the video and see if you can figure out what the problem is. Do you see it? I'll mouse over the error. And Eclipse says the local variable more numbers may not have been initialized. It's easy to forget that you have to create an array with the new keyword, and we haven't done that here. We're trying to assign into an array that does not yet exist. I think because Java does have that syntactic sugar that makes arrays feel a little more like primitives, we can forget that they're objects that need to be created with the new keyword. So that will be solved by writing more numbers equals new int and then a size in brackets. But I'm going to leave that to you to fix, and I'll comment it out and move on to error number 5. No help from Eclipse with this one. For this example, I've defined an array of die objects, so die open close square bracket dice, and then I did not forget to initialize it. I have dice equals new die 5. Next, I send the roll message to the die at index 0, die sub 0 dot roll. Pause the video and try to figure out the error here. Did you figure it out? Let's run the program and see what happens. Null pointer exception. Dice sub 0 is null. So this time, I didn't forget to instantiate the array, but I did forget to put objects in the array. When we instantiate an array of objects, the locations in the array are all null until we store objects in the array. I would call these 2 errors failure to initialize errors. We need to remember to allocate space for an array or an array list if we're using an array list. And then, if our array is filled with objects, we need to make sure we're instantiating objects to store in the array. A null pointer exception is an unchecked exception, meaning there's something quite wrong with your code if this error is being thrown. If you're getting this error, you need to figure out why you think there's an object in the array when there isn't. If you expect your array to be partially filled with objects, then you can check if the array location is holding null with a simple test for equality, equals equals or not equals, before trying to send a message to the object. Okay, we've advanced to the last category of common errors. Let's look at example 6. In this example, we have a comment, make a copy of numbers, and double the values in the copy. We have the code int, open close square bracket, numbers2 equals numbers, and then a loop over numbers2 with for int I equals 0, I less than numbers2.length, I++, and inside the loop, numbers2 sub I times equals 2. We then have a loop that prints both the original numbers array and the numbers2 array. Before I run this code, pause the video and figure out what's wrong. How'd you do? If you remembered that the code numbers2 equals numbers doesn't actually make a copy of the array, you're doing great. It's easy, again, to forget that arrays are objects. When we use an assignment statement to assign an object, we're making a copy of the reference to the object and not the object itself. After that line executes, both numbers2 and numbers reference the same array in the heap, meaning that our changes to numbers2 are also changing the original array numbers because they are the same array. When we print, we get the same values printed twice. You can refer back to the video called Arrays and Methods and the Right and Wrong Ways to Copy an Array for 2 different methods of copying an array that will ensure you have a completely new array with new data once you've made the copy. Let's look at example 7. Here we're defining a new integer array called more numbers and assigning to it the result of the method call double array, passing in numbers as a parameter. We then print both arrays. Can you guess what the issue is here without me showing you the double array method? Pause the video and take a guess. If you guessed that the double array method is actually changing the array that is passed as a parameter and not creating and returning a whole new array of the values doubled, you're correct. Here's the double array method. It's modifying the array passed as a parameter in place, then returning that array. The person who wrote this method may not have remembered that the array passed as a parameter is a reference to the original array. Therefore, any modifications to it in the method are modifications to the original array. The return statement makes it seem like this method is producing a whole new array, but it isn't. The way to avoid these errors is to make sure you have a good understanding of when you have multiple references to the same array in the heap. A good rule of thumb is if you don't see the new keyword, you might be working with the same array. Assignment statements and parameter passing simply copy the value on the stack, giving you multiple references to the same array in the heap. If you're invoking a method you didn't write yourself, make sure you know whether that method is modifying your array parameter in place. On to our final category of errors. Here I have a very small block of code that's using our original numbers array. For int I colon numbers, system out println numbers sub I. Pause the video and see if you can find the error with that loop. Did you find it? I'm going to run the program and, well, that looks fine. Am I sure there's an error here? Let me make a slight change to my array. I'm going to put 20 in as the second element in the array. Can you predict the output? I'll run it again. And now I get an error. Array index out of bounds error. It's trying to index into my array with 20. So what's going on here? This loop is an enhanced for loop in which the loop control variable takes on the values in the array. So each time through the loop, I will take on the next value in the array. But inside the loop, we're using I to index into the array rather than treating it like an array value. This kind of error is very common for new programmers. It's hard at first to distinguish between indices into an array and the array elements themselves, and this loop is especially problematic because the loop control variable is badly named as I, implying that it's an index. It should be renamed as element or something that makes it clear it's a value in the array and not an index into the array. One lesson here is to always name your variables carefully. The programmer who used I here was either lazy with the variable name, or they didn't understand that the variable is taking on values in the array and not indices, so they used a misleading name. Another lesson is to not trust the names of variables and read the code carefully to make sure you understand what the variable is really holding. The debugger is going to be your best friend if you have an array error. Let's step through example 8, which will be brief, and then we'll debug example 7. First, I'll set a breakpoint on my loop header by double-clicking in the blue margin, and then I'll click the bug. Eclipse asks if I want to switch to the debug perspective, and I do. Now I can see my variables in the pane on the right. Notice the array numbers can be opened up, so I'll do that. And now I can see the values in the array. Now I step over, and I can see that I is 0. The values in the array make this example extra confusing because in the original array, before we added the 20, the values were the same as the indices. But that value in I is a copy of the value from the array at index 0. I'll step over, and it prints to the console. And I step over again, and I can see that I is 20. If you're debugging this, hopefully at this point the penny drops, and you realize that you are not iterating over indices, but rather values in the array. Now when I step over, we try to index into the array with 20, and we get the exception. Now let's put a breakpoint on example 7's call to double array, and click the bug. Here I'm going to want to step into that method call so we can see the method execute. Pay attention to the ID of numbers. Notice when I step up into the method, the ID of array, the local parameter variable, is identical to the ID of numbers. This is the same array. As I step over this loop, I can see the values in the array changing. When I return, Eclipse highlights the numbers array in yellow, indicating to me that it's been changed. When I step over the assignment statement of the return value to more numbers, I can see not only that more numbers has the same values as numbers, but it has the same ID, meaning they are the same array in memory. If I were to assign into one of the arrays here, I'd see both of them change in the debugger. When you're debugging a program with arrays, pay attention to the ID of the arrays so you know when you have separate objects. Eclipse is showing these variables as two separate variables, which can make it seem like they might be different objects, but the ID tells us they're the same object. You should also step through all looping algorithms so you can watch what's happening one step at a time. Sometimes we just need to slow down and watch what's happening to find our bugs. That's what debuggers are for. Now, if for some reason you don't have a debugger or want more information before you debug, you can always add print statements to your program to examine variables at specific points during execution. I recommend when you do that you put a label on whatever you're printing so you know what you're seeing. Otherwise, after a few print statements, it can be hard to keep track of what's getting printed when. When you're done with a print statement, you can comment it out in case you want to use it again later. In this video, we looked at some common ArrayList errors, how to program defensively to avoid them, how to test for them, and some debugging strategies for arrays. Our errors fell into roughly 4 categories: off-by errors, failure to initialize errors, array reference errors, and value index confusion. To thoroughly test an array program, you'll want to design test cases with typical arrays, as well as arrays that are very small and very large in size, as well as arrays that represent edge cases based on what your algorithm is doing. For example, you might want to put values of interest in different locations in your array, especially at the first and last indices. When you're debugging a program with arrays, make sure you pay attention to the ID of the array variables. The ID will tell you when 2 array references are pointing to the same array in memory. I hope you found this video interesting and helpful. As usual, I've included an auto-graded exercise in the description of this video so you can practice with this code, and the video code is available in my GitHub repository. There's a link in the description. As always, have fun and keep coding.